seems to work. Okay. Firstly, there's an aspect of the lab that is kind of, how should I say? Well, I should start screen recording first. Remove pin. Hopefully this works. Yes, so there's an aspect of the lab that isn't really Ohm's law, but it's in the Ohm's law section, which is this one. So for this lab, I think it's a good idea to do this slide 5 because it gives you like an eye towards, in particular, lab next week, which is Kirchhoff. Kirchhoff's rule is an idea where if you have a circuit, everything that's given is used. So if this thing is 3.3 volts and the current goes around and it passes through 2 circuit elements, because those 2 circuit elements are the only 2 things in the circuit, they are what's using the 3.3 volts, and they must use it like exactly because this is 0 volts. And so 3.3 needs to turn into 0 eventually. That's Kirchhoff's rule, and you'll learn it next week. So this whole slide 5 is basically Kirchhoff's rule, because what you're doing is the idea that if you take 2 of the same circuit elements and test the potential drop across one of them, you can double it. And so as you see here, that's not quite zoomed in as much as I would like. Let me see if I can stop share. But I want to share. Not exactly sure how to share and have. I'm going to say, pin that, make it 1 and then bigger. That kind of works for now. Is there a way for me to make this? No, that's just my, okay, yeah, it's my phone camera being in that direction. Wonder what would happen if I turned it the other way. Anyway, at the moment, we have the circuit set up so that the plus line right here at the top is connected to the 3-volt battery, and the negative is connected to ground. And so this out, this A7 port out. Okay, my cord just detached inside the IO lab. Not good. Anyway, this is exactly what you're seeing on the screen. The IO lab is the battery, so that's the bars and the plus. And then I have 2 resistors. That V you see on the screen will be this cable. And the thing just came up again. Will be this cable. And so we are putting it around one of them. So in theory, what we're doing is measuring lab, make this a bit smaller. Oh, the IO lab turned off. So this is measuring something that is roughly, if I stop and highlight it, it is roughly half of the actual device. This isn't really necessary. And the reason it's not necessary is once you get to the actual Ohm's law, let me open this tab, it's just distracting you. Once you get to the Ohm's law, actual Ohm's law, like slides 6 and 7 and such, the values that you're working with in the lab are so much bigger than 3 volts. So like the way that Ohm's law works is you have a voltage, a current, and a resistance. You're measuring the current and seeing, does that work with Ohm's law? So the thing that you're going to measure is current. Well, in an indirect way, you're going to measure current. And then you're going to say, okay, does that current, so this is the kind of the voltage that you're measuring, which is why we use this little trick of a much smaller resistor that actually has no effect on the circuit, and measuring the current that's going through that. And that's where that little trick here comes. If you're dividing by 1, it's the same thing. So you can kind of convert your voltage to a current in that respect. And the big question you're asking is Ohm's law correct? So this is, for instance, what you're seeing from the IO lab. Something like this. So that's what I had from my slide 6 result. Yeah, slide 6 result. And so here's my voltage, which I know is really the same thing as the current because I'm dividing by 1. And then I have my current multiplied by the actual resistor in the circuit that I'm trying to look at, the voltage drop across it, which is 10,000. So this really small number, the milli, and the very large number is going to end up giving me a not super precise number. So this like measuring the voltage across one resistor and then doubling it, like this difference from 3.3 is not really important because you're only going to get so accurate results based on how the circuit works. And this is just to show you that. I'll switch back to that other camera. I can stop sharing this one. And okay, this is just to show you that you can measure instead of just taking the 3.3 volts for granted, you can measure it a bunch of different ways. I should be screen sharing actually. If I plug it into the actual strip, like right next to this, so this red wire is going to 3.3, and I plug this right next to it, that should be exactly 3.3. So screen recording really quickly. That view, that. 7 record. Yeah, so that's almost exactly 3.3, just a little bit less. Again, that accuracy really isn't needed because of the numbers that you end up working with. Another way to do it is, there's no reason to use the breadboard in this case. You can just connect a wire to the 3.3 volts and touch them together. More closely. So you can't see it, it's off the screen. There it was. So that's just ambient, just me holding it out in the air and touch them together. That's 3.3. Let's prove. Highlight that. And it's practically the same thing. So that like, you know, if my battery is a day old and it's not, you know, exactly 3.3 volts, doesn't really matter because the resistors you're using in the lab are so much stronger. They're kilo, right? That's the K ohm is a kilo ohm. It's huge. So just to clarify, the kind of prep for next week that you'll be doing this week without even knowing it. Like I wouldn't have made this video if it mentioned the word Kirchhoff in here.